Hello there, Sandy Hughes from FormaServe once again. Welcome to this how-to on IBM I video set integrating a Raspberry Pi Pico with your IBM I. In today's video we're going to explore the fascinating world of the Pico microcomputer and how you can use it to send data to your IBM I. Whether you're a seasoned IBM I user or a beginner, you're in for a treat. First, we'll dive into the details of the Pico microcomputer and its capabilities, and then we'll show you step by step how to integrate it with the IBM I. So sit back, relax and get ready to be amazed, because trust me, I was blown away when I first started playing with this. And to be honest, it takes a lot to get me going these days. And ting ting, to get a notification of when the next video in this series is released, please don't forget to subscribe to our channel, like and subscribe. It really is appreciated. Thank you. This is the Raspberry Pi Pico W. Yes, it really is that small, or I've grown a lot. No chance, Andy. A microcontroller from the Raspberry Pi organisation. The big chip on the end is the wireless component. It has a power socket, USB, and a load of GPIO pins, very similar to the Raspberry Pi. And it also has a reset button when it all goes wrong. These microcomputers cost about £5 in the UK, probably about the same in dollars or euros, so very cheap. They are a lot easier to get as well than the Raspberry Pi at the moment. Looking at some of the projects out there that use the Pico, one user had a Pico detecting if he had left his garage door open. If it was still open after a couple of minutes, it sent him an alert. Great idea. So for £5 we can have these anywhere. They really are a great bit of kit. What do we need to program them? These little beasts use MicroPython for programming. So very similar to Python with a few bits stripped out. We can load a Python program to be executed when the Pico starts up. It can then be left wherever you need that has a power supply, hence the guy with the Pico in his garage. Firstly, we need to use an IDE that knows all about the Pico. For that I will use Thonny. Probably said that wrong, probably spelled it wrong. Yes, I know, another IDE. But this one really does help with the Pico. The download is in the link below. Right, the first thing we have to do is make sure our IDE is connected up to our Raspberry Pi, the Pico. So down the bottom here, it should say MicroPython Raspberry Pi Pico. It's on COM4. It's plugged straight into a USB port on my PC. So that's all looking good. Another check to see if it is actually connected to the Pico is the shell windows down the bottom third of the screen. You can actually type in commands directly if you want to. Very handy. And we have the code up here. Nothing special really. Got a few imports at the top. We need variables for our SSID and our password. Nope, you're not going to see those. And then we have a function called connect. And that goes through and tries to connect to our network. So we can see here WLAN connect with the SSID and the password. And then we've got a do loop, a do while loop. And it's actually checking if it's connected. If it's false, it comes down and says still waiting. And it goes through this loop, just sleeping for a second at a time. When it is connected, it drops out and goes into this line here. It gets our IP address. And then it goes down and prints out connected on IP address, and it returns the IP address for us. So down the bottom, we've got a variable there called IP, and it's calling that function, two brackets around it, so it's executing the connect function. So it goes through this until it gets a connection. And we've got an interrupt there as well, so if we want to stop it at any time, we can just interrupt it. Control C works well. And to test this out, let's give it a run. We press the big green run button at the top, and you can see there waiting for connection, and it's now connected. So we've got an IP address on it. We can get into that whatever way we need now. It's connected to our network. Great result. Now we have the code to make a Wi-Fi connection. Let me show you one other program on the Pico. What I forgot to say when I was rambling on about the spec, it has an onboard LED light and also a temperature sensor that is part of the RP2040 microcontroller chip. In this next demo, I'll show how we can run the web page and toggle the LED light on and off. Then I'll show you how we can get the temperature sensor to send its information over to the IBM I. LED light first. Right, demo time. Got the program loaded up here in Thonny and the shell down the bottom. Press the big green button, see what we get. Please connect, please connect. Waiting for connection. And there it's connected to our 10 network with an IP address of 118 and it's listening on port 80. Typical for HTML pages. So let me open up a browser, go over to the other screen and hopefully that should pop up. Right, let me go to that web page 10.000.118. Yep, got it right. Press enter and straight away it comes up, hello from Pico W. Hello to you. So very simple web page, got a couple of buttons on it, turns the light on, turns the light off. So hopefully this will do the LED for us. I'm not sure you're going to be able to see this to be honest, but if not, I'll have a mess around with it so you can see it. So turn the light on. It says on the bottom of the screen, LED is on. Turn it off, turn it on, turn it off, so on and so forth. Hopefully you can see that. If I go back to Thonny now, let's close this down. You can see all the connection messages there. Just roll back a bit to where we started. We can see a client was connected from port IP address 105. So that was my PC and it was thrown out a HTTP method of get. So you don't really need to know about this, but you can see how it's talking between the two. So that's the demo, switching the LED light on and off. Very impressive. Right, let's have a talk through the coding. I'm not going to narrate each line, I'll just highlight the main sections. Firstly, we've got a load of imports, nothing special there. And then on line 8, we got a variable, int LED, and it's looking for the machine pin. So that will tell us whether the light's on or off. Next, we have some wireless stuff. And then it tries to connect to the Wi-Fi for the SSID with the password variables. In the next part we have an HTML variable that's just containing a bit of HTML. Nothing special in there at all. It's HTML, it's got a header, it's got a body where it shows the lights, where you can switch the lights on and off, end in the body and then end in the HTML. Nothing special there at all. Next we have the Wi-Fi connection, very similar to what we had before. It goes through in a loop and makes a connection. If it doesn't, it drops out and fails. Let me scroll up to the next bit. The first part here is all to do with the Wi-Fi connections, just making sure everything is okay. Next it gets the socket address for port 80, the HTML port we will be using. Then it binds to that address and port number. Then an informational message to let us know we are listening. And the last line is to initialize the variable to hold the status of our LED light. Then we have a continuous while loop. The first part of it is to get the details of anyone trying to connect to this IP address and port number. Then it prints out the incoming request. It then inspects that incoming request to see if the light is requested to be on or off. Then we have a statement to check if the LED light is on or off. It then builds the HTML string with the status codes of the light. Then it sends an HTTP code of 200 for all is good and sends the response. If any of this hits any issues, it drops into the exception block and closes the connection. For the next part, we're going to set up ActiveMQ. ActiveMQ is going to sit in the middle from the Raspberry Pico to the IBM I, and it's going to route messages between the two. So the first part we have to do, we have to make sure that we have ActiveMQ installed on our IBM I. a quick yum. It's better with the cursor there. A quick yum installed ActiveMQ. I've already got it installed on my box, so hopefully that should come back and tell us it didn't like the first FTP site. And it's come back already installed and the latest version, and it has nothing to do. So next we have to do ActiveMQ start. That gets it up and running, up and listening for things. It's chugging away and it looks like that's finished. So ActiveMQ is now up and running. I can do ActiveMQ status just to make sure. And that's all up and running. So now we point our browser at ActiveMQ and see what it says. Right, let me go into ActiveMQ. Start a new tab. Go into our Galatea. And the port number is 8161 for ActiveMQ. So that is ActiveMQ running on our box. And what it'd be doing, it'd be taking messages from the Raspberry Pico and placing them on our IBM I. So we need two pieces of software here. One to send the messages to ActiveMQ, and then something to read ActiveMQ and populate a database for us. Let's go into the Manage ActiveMQ broker. Ask for a user ID and password. Hopefully I got that right. So here we can see, and we want to go into the topics part. So everything with ActiveMQ, it works on what they call pub and sub, publish and subscribe. So the PicoW is going to send out a topic, and then we have the subscribers to that topic. So we've got a queue down here of IoT, and we're going to be sending things to that queue from the Raspberry Pico. So we should see those numbers go up when we're sending the information. So that's all we have to do with ActiveMQ. It's what they call a broker, and we're going to use the protocol called MQTT. So ActiveMQ likes MQTT, that was difficult to say, MQTT. So that's going to sit in the middle, receive the messages, and then somebody's going to be subscribed to it, and they're going to come away and take those messages. First part of the coding is the Wi-Fi connection, not going through that again. And then we have some initialization of some variables. The sensor is looking at the status of pin 16. And then we have the MQTT broker. I think I said too many T's there, but never mind. The broker, which is our IBM I on 10.00.36. And then we just put a client ID, the Pico W. And the pub and sub message there, the topic. Topic is only going to go into test for the moment. And the Pico W for the name. And count to 0. And in this part we have a couple of functions. And the first one connects to our MQTT broker, the server. So that's our IBM I, it's going to connect to that. And the second function is a reconnect, just in case the first one fails. So in a try loop, then we've got the client connect, MQTT connect. So it's going to call that function and check for any errors. If there's any errors, it will try to reconnect. And then in a continuous loop, while true, it goes through and makes sure the sensor value is above 0. And it goes down and it counts, builds a message topic and prints it out, and then sends it to the client. Then it waits 10 seconds and goes round again. So that rounds it off nice and neatly. At this point, there is nothing we need to do to the broker. It just sits there waiting for messages, and if anyone subscribes to the topic, it makes those messages available. Let's give this side a quick test. So we've got a split screen there, got ActiveMQ. I'll just refresh on that. You can see it's got 15 messages already in test. We'll leave those alone. But we'll run our program now in Thonny and come up hit the big green button, and down the bottom in the shell it should be trying to connect to our Wi-Fi. Hopefully it will connect. It's connected to that. It's connected to the MQTT broker, and it's got temperature is 27. Should wait 10 seconds, and exactly the same. So it's going through now. In that loop, every 10 seconds it's sending out a message to the MQTT broker. So if we refresh our ActiveMQ, you can see we now have 18 messages. So that's talking to them, and it's put them on MQ. So that's great. That's exactly what we need. I've made a quick change to my program on line 24, so it sends the messages to the IoT channel on ActiveMQ. Come across to there, press refresh on it now. So we can see the test ones have gone up to 95. There's nothing in the IoT one now. So when I run it, make it down, it makes the connection again. Hopefully it makes the connection again. Yeah, we got the connection to 118, and it's connected to the broker, and it's sending out the messages now. So every 10 seconds it'll come down there and send out the message. You've got to remember that this temperature sensor is on the board, on the Pico board itself, so it's right on top of all the components as well. That's why you get some of the temperatures seem a bit high. It certainly isn't 28 in here today. I'll go across to ActiveMQ and I'll refresh that. So it sent out the 4 messages, we can see from here, and it sent out the 4 to there. So they're just sitting there waiting on the queue. The next part, we're going to pick up those messages and store those in the database. For ease and quickness on the IBM I side, I'm going to be using NodeRED to pick up these messages and store them in the database. So here we have NodeRED. I'm using the beta version on the IBM I. Had no problems with it, quite happily use it. We've got 4 blocks here. I'll show you one by one. First block is just going to execute our DB2 statements. So our SQL statements gets passed into here, and they get executed, and if they get any problems they come out in a debug mode. No problems at all. So the first thing I wanted to do when I've got this information is create a library. Create a library, create a schema. It's all done by this block of code here. We have a timestamp there just to fire it off. It goes into a function and then it goes into a link. And block 4 is going to create a table in the schema we have just created. It will be called sensors, and again that gets passed to our DB2 node to get executed. So the last one goes into, it's going to receive the MQTT messages from ActiveMQ, and we're going to subscribe to the topic of IoT. That's all we need to do there, nothing special. Once we receive a message from ActiveMQ, it goes into our function node to insert the data into the sensors table with a quick SQL statement. That then gets passed to the DB2 node to get executed. I'll bring this in over here. So if we just bring this down, you can see that they're sending the temperatures. So I'll just bring this over to here for now. We can see these messages are actually coming in. Payload there 22, payload there 24, so on and so forth. Right, let's give this a test. I'll start up run SQL scripts and run a quick SQL statement. Select everything from IoT.sensors, semicolon at the end, and then Control R to run it. And we can see all our data. Let me move it up a bit. Yep, all our data's there, so looking great. If you need any further details about open source or IBM I, check out all our videos at learning.formaserve.co.uk and the articles we have written for Powerwire.eu. I hope you find them useful, and let us know if there are any other topics you want us to cover. In this video we covered some significant features and benefits of IBM I. We hope you found this video informative and helpful. Learn from our experts and boost your skills on IBM I. Visit our website today and sign up for our training courses, or buy us a coffee to show your support for our creative work. Thank you for watching, and we'll see you in the next video.